Fortin's barometer. It is an improved form of barometer constructed and used in the laboratory. It consists of a cistern of mercury. The mercury level can be adjusted by means of a screw S provided underneath. A brass tip is fixed above the mercury level, which coincides with the zero of the scale of the barometer. A narrow glass tube filled with mercury is inverted and inserted in the mercury in the cistern. Adjusting the screw S, the mercury level can be made to coincide with the tip T. The reading of the mercury level M in the tube gives the atmospheric pressure. A vernier is also provided for accurate measurement of the reading. We can measure the atmospheric pressure accurately with Fortin's barometer, but it cannot be shifted casually from place to place. So, it is used as a standard barometer.
So we have two columns, one saying minimum and one saying maximum. You have two mercury lines here and a little bit of blue, I don't know whether you can see that, just above. When the temperature rises, it pushes the blue piece upwards and it leaves it at the highest point, so it shows you the maximum temperature that it has been. When it falls, it shows you here on this column, it pushes the blue piece upwards and it shows you the lowest temperature that it has been. The two mercury columns, one reads again, the gauges read backwards on both sides, one obviously this way and one obviously downwards. These should read the same temperature even though they look different, but they should show the same temperature at all times.
The TB3 is our most accurate rain gauge because it possesses a siphon to control water flow. First, the rain will fall into the gauge's funnel and stream into the tipping bucket mechanism, which looks like a seesaw device that you can tip up and down. It is positioned so that one of the buckets catches the water while the other bucket drains it. The top bucket will fill with rainwater, and once it is full, the weight of the water will cause the seesaw to tip. When it tips, a reed switch will momentarily close, completing an electric circuit and allowing the data logger to record an electric pulse. Each time it tips, this equals 1/100th of an inch of rain. The data logger at the mesonet records the tips and calculates rainfall amounts every minute. The TE gauge serves as the backup gauge in case the TB3 breaks down. It functions the same with the exception of quality. Like I mentioned previously, the TB3 has a siphon which allows it to